All right, so we are, as always, starting with a two-tailed version of our repeated measures t-test. Step one, we're going to state our hypotheses, and as always, there are two of them. That never changes, as we know. And for our two-tailed test, we're still making the same general predictions. The alternate hypothesis is going to predict that there will be a difference between the first and second set of scores. And the null hypothesis is, no, there won't be any change, there won't be any difference. That treatment is not going to make the second set of scores, the second measurements, any different. Just like we did last chapter, let's think about the null hypothesis first. It's saying that there won't be any differences, that the score you started with is the score you'll finish with. Well, let's think about that for a second. If that was true, if we were calculating a person's difference score and that was their case, they had 5 points the second measurement minus 5 points the first measurement. So their difference score is a 0. There's no difference between the first and second measurements. And so the null hypothesis is saying that's going to be true for everybody. So when we average these difference scores, 0 plus 0 plus 0 plus 0 plus 0 divided by however many is going to equal 0. So the null hypothesis is that the treated population mean of difference scores will equal 0. Now, I mentioned in the previous video that I'm putting the subscript D on everything where it's not really required. This is a place where it must be placed. This subscript of a D there for different scores is not optional. So if you are putting this in for a quiz or an exam, you either have to put that symbol in there, or again, you still have the option of typing it in English, but you would want to type it exactly like this. The treated population mean of difference scores will equal 0. You have to use all of those words or it's not correct. The alternate hypothesis says, hey, those scores will be different from each other, so when we subtract them, we're not going to get a 0, and when we average it, we will not get a 0. So the alternate hypothesis is the treated population of different scores will not equal 0. Again, we have to have that subscript of the D there, or the word treated population mean of different scores, however you're presenting it to me. For a two-tailed test, this is the only way to write it. There's nothing else for us to write. It's this or it's wrong. So that is our step one, our first step on getting our hypothesis test completed. Step two, we know, is to pick an alpha level and determine our critical regions, setting our criteria to make a decision, right? This, again, is the same table we've been using for the last two chapters. It's still the T distribution table. So we still need to know the same three things. We need to know if it's a one-tailed or a two-tailed test. Right now we're talking about two-tailed. We need to know what our alpha level is. Does the problem tell us to run it at 0.01 or 0.05? And we need to know our degrees of freedom. This goes back to the way we did it in Chapter 9. Remember in Chapter 10, we had to get the degrees of freedom from sample A and the degrees of freedom from sample B and add it all together. There is only one sample here. So we're going back to our regular old n-1. The number of people in the sample is the best way to think about this. The number of people in the sample minus 1. Or you could say it is the number of difference scores minus 1. But remember, once we have different scores, we don't care about raw scores. So the fact that there were two sets of raw scores is not relevant here. We're not doubling anything up. Just the number of people in the sample minus 1, or the same way of saying that is the number of different scores in the sample minus 1. We get into our T distribution table. We find the correct header, one-tailed or two-tailed. Find the correct alpha level. Move down, find our degrees of freedom. If it's there, great. If it's not there, go to what's closest. If there's a tie, go to the one that gives you the greater T value. So off of that, we get our critical T. And again, we were setting up for a two-tailed test here, so it's positive or negative. I think this table is to 3 places, right? And then make our little roadmap to make our decision when we get to step 4. So that's step 2. In the next video clip, we're going to look at steps 3 and 4.